Hello, I'm Robert Smitty Smith, and welcome to Engineering Tower Room 141, the undergraduate workshop. And this lesson is going to concern fasteners. What are fasteners? Fasteners are things, devices that fasten things together. And in this world, as mechanical engineers, you'll mostly be dealing with these babies. This is a bolt. This is a grade 5 bolt. This is identified by 3 radial hash marks on the end. And it has a certain length, shank length, unthreaded, threaded length, diameter. A grade 5 means that it has a certain proof strength, it has a certain yield strength, and it has a certain ultimate strength. And as mechanical engineers, you need to know these things. Now, we're going to discuss more than bolts. One of the first fasteners that you'll find in everyday use, a simple nail. It's nothing more than a metal pin. Now, after nails came these little darlings. I'll try to hold them in my hand steady so the camera can see them. These are rivets. These are nothing more than a nail without a sharp end that are inserted in a hole and then either squeezed and flattened so that basically you have heads on both sides. These are rivets. This is another rivet type fastener. It's for going in blind holes. It's commonly called a pop rivet. It has a hollow part where this one is solid, and there's a mandrel that goes down through the center. It has an enlarged hardened tip, a special rivet tool grabs it. The hardened tip is pulled inside, making the shank swell. Now, if this was inserted in a hole, eventually that would keep pulling until that hardened tip butted up against the material it was in, locked down, and then the shaft breaks off. May not do it because there's nothing for it to lock against here. Yes, hear the pop, and that generally means there's your rivet. The part of the mandrel stays inside. The broken off stem is discarded. This is called a blind rivet or pop rivet. Okay, rivets. Now, some genius hundreds and hundreds and hundreds of years ago took a rivet, cut some helical serrations on it, and made a screw. This is a screw fastener, and it is a straight slot screw fastener. There's also a certain head shape to this, which will identify it as belonging to a certain family. And its diameter, the pitch of the thread. Pitch means that it's the distance between the threads. Here's another screw fastener, except this time it has a Phillips drive instead of a straight drive. And then bolts are basically screw type fasteners with a hex drive. And you can have coarse threads, you can have fine threads. You can have galvanized zinc or zinc type coating to help prevent corrosion. You can have a cadmium coating like this golden color this one has, or you can have a black oxide coating. So you can have same fasteners, different coatings, and all like this. Here's another fastener. This is an eyelet fastener. How about this? Here's a square nut like would be found on farm equipment or industrial machinery. This wood screw. Notice the very, very large pitch because it's got to grab lots of wood fiber to get a grip. Washer. And there are different standards of washers. There's USS, which is United States Standard size, and then there's SAE, Society of Automotive Engineers, have their own standard. They're apples and oranges. The internal ID and the OD will be different. Also, the hardness level of washers can be different. All of this type of information you're expected to know as mechanical engineers. Fastener materials and what they do, the proper application, that's the air you breathe, the water you drink as a mechanical engineer. And you have to learn this stuff if you don't already know it. This is a very popular common side. This is a socket head fastener. Uses an Allen drive, not the correct size there. Let me these are Allen wrenches. These are the L-type Allen wrenches. This is what's known as a T-handle. These are hexagonal drives, as you can see from the larger ones. And they're in metric or fractional, and they fit inside the fastener head. You have a hexagonal socket, where here you have the hex on the outside, here you have the hex on the inside. And you use an Allen wrench to turn it. And as you can see, you can generate a lot of torque. So, you can also, very, very popular fasteners. Now, markings. Let's go back to our big grade 5 bolt. 3 radial lines denotes a grade 5. Here on this sheet, which will be posted in the workshop, is how to identify the fasteners we are required to use to have sufficient strength to be safe in an automotive type application. Here we have our 3 radial lines. Here we have a fastener with no lines on it. Let's see if I have one of those handy. Yes, this just has some no, that's a metric. That's another grade 5. We'll take my word for it. The nail has no marking. So if you have no marking, that means it is a grade 2 or less. And it has a certain strength and proof that you can use, certain yield. Grade 5s are stronger. 6 radial lines. The way you get the grade, you take the number of radial lines exposed, add 2. If you have 3, add 2, that gives you a grade 5. If you have 6, add 2, that gives you a grade 8. Grade 8 is a very high quality fastener. It's used in aircraft and racing vehicles under very high load components. Now, what about metric fasteners? Metric fasteners have their own. Here's a metric fastener, and you can tell because it has a decimal number. It has an 8 decimal point 8. Here we have an 8.8 and then a 10.9, because decimals and inches are apples and oranges. They have a different way, but they have equivalent strength. So here's the strength. It's all on this chart. You're responsible for knowing this material 100%. Now, that has to do with head markings and grades. What about just basically how fasteners are identified? Their types. What types of fasteners are they? Are they a screw? Are they a bolt? Are they whatever? Here's a sheet that will give you that. How fastener measurements are notated. You're expected to know this. This is your life's blood as a mechanical engineer. When you create a drawing and you need to use a bolt to attach 2 parts together, you have to specify the size, the grade, everything about that bolt that's pertinent, you have to specify it. This will tell you how to do that in a professional manner. You can't just say, oh, just put a bolt that's about a 1/2 inch diameter and about 4 inches long. That's totally unprofessional. You got to specify everything about that bolt that's pertinent to that application. That's what a mechanical engineer does. Now, how about measuring fastener diameter? If you have a fastener and you want to know what it is, or if you're specifying a hole or an attaching point with a fastener, you need to know how they're measured. This little sheet will tell you all about the mean root, pitch, all like that. The pertinent information you need to know. Length. Here is how lengths are measured for different types of fasteners. Here we have our socket head cap screw. The length is always from under the head to the end. Here we have an eyelet. Where is it measured from? It's measured from the bottom of the ring to the end of the shank. So what about this? Here we have, there's a fastener right there. You use the entire length, or you use under the head. You need to know that. So there's one that uses the entire length. That's a countersunk type fastener. And if a drawing has specified use 4 MS number 10 X 1 inch fasteners, what does that MS stand for? What does that 10 stand for? This is what these sheets will give you. Here is fastener type charts. Here are wood screws, socket screws, J-bolts, hanger bolts, eye lags, eye bolts, set screws, lag screws, sheet metal screws, self-drilling sheet metal screw, SMS, sheet metal screw. This isn't rocket science. This is basic simplicity at its finest, but you have to know that SMS is sheet metal screw, or self-drilling sheet metal screw, sheet metal fast screw. Okay, so MS, machine screw. Just that simple. Don't overcomplicate it. Here's some more fastener types. Flathead, oval head, hex head, round head, another hex head with a built-in washer, all the different types. How about this one is a mix, a hybrid. It has a straight slot, plus it has the cross in it, so a Phillips type 4-point screwdriver can turn it. How about a combination? Just that simple. But you have to be familiar with this terminology. This is the air you breathe as an engineer. How about, okay, we got fasteners. How about the other end of the fasteners? How about nuts? You are expected to know every nut on here and when it is used and when it is not used. You've got hex, nylon insert lock, jam, acorn, cap, square, T, coupling, etc. They're all right here. Just look at them and learn them. Nothing to it. Underneath the nuts goes washers. Here's different families and types of washers. Fender washer, flat washer, external tooth locking type washer. Very, very simple. And here, speaking of washers, is a washer sizing chart. So if you have a washer and you want to know what size it is because it's just right for what you're trying to do, then you can go, well, it's not big enough to be that. It's not big enough to be that. It might be that. It's too big for that, so that's a candidate. It's too big for that one. It's about that one, and it's about that one, so it's between these two. And the best fit is this one. If this scale, anytime you have this kind of scale information, there's generally, you're given a scale. You need to know when this printed, did this print 1:1 or did it print 0.9:1 or 1.1:1? So they give you a scale here you can check. If we take a 6-inch ruler, a little 6-inch ruler, 0 to 6, put the end here, that's pretty doggone close right there. That's 98% accurate. So I can trust the chart will be accurate. Same way, if I need to know what size bolt I need, I could literally take the bolt and hold it up there to see if it overwhelmed the hole or not. Very valuable too for you to use here in the shop till you get used to these particular families. Here again, USS, United States Standard Size. SAE, you will find the SAEs on this side of the page are all SAEs. You will find that they will fit the bolts snugger than the USS. The USS are the type of fasteners you would use on lawnmowers, yard furniture, low stress type applications. The SAE are more in automotive. They require a tighter fit, cleaner fit, that sort of thing. So that's your two basic families, is SAE and USS. Now, finishing up, here's some more charts. They will be available for bolts. So as you can see, you can actually overlay the darn thing, measure the threads if the scale is accurate. But here again, I'm warning you, check your scale so you have an idea if you're high or low. Let's check the scale here on these. Okay, that one is 1/4 of an inch short of 6 inches. So a real bolt will be slightly larger than the virtual bolt, but it will still be pretty close, and you can use just a visual check to see on you can easily tell this is a fine thread fastener by the fine threads on this side and the coarse on this side, and you can use it to help you match up. Here we have screws, different sizes. That's a 632, that's a 1/4 20, that's a countersunk, round head. Here again, here's some metrics. Now the pitch on metrics is based on millimeters. If you see a 0.8, this number is the diameter. The first number, 5 millimeter, that's the diameter of the shank of the fastener. The shank is the body. Okay, so a 5 millimeter X means next dimension by 0.08. That means it's 0.08 millimeters from one tooth to the next tooth. From one thread to the next thread. If it was 1.0, it would be 1 millimeter exactly. So that's the way metric fasteners are sized. That's 1 1/4, that's 1.0, that's 0.70. So that's how metrics are fastened. Same way in the fasteners. You can see 16 millimeter in diameter by 2.0. That's the pitch from the peak to the next peak, 2 millimeters. Very, very simple. With fractions, it's a little bit more complicated. 7/16 is the body diameter of the shank. 14 is threads per inch. We're back to King Henry VIII's little finger measurement there, which is 1 inch. So in 1 inch, if you picked any inch and you counted the teeth, the threads, you would get 14. On this one, you get 13. On this one, you get 12. On that one, you get 18. Just that simple. SAE stuff is based on threads per inch. Metric stuff is based on how many millimeters from thread to thread. You can use these charts to help you size. They're easily available, easy to use, and that will get you started off correctly in the wonderful world of fasteners.